All right, today we're going to be looking at Sig Fig calculations, and here is our Sig Fig worksheet. We have 10 questions that are going to be asking us to make some sort of a calculation. We have to use our rules of significant figures and how we are supposed to specifically identify which ones to keep for calculating, whether it's multiplying and dividing or adding and subtracting. Now, when we are multiplying and dividing, we're looking specifically at the total number of sig figs in each of the numbers we're starting with, and we can only keep the least amount from either one or all of them that are included. If we're adding and subtracting, we are looking at the number of decimal places in the least amount for each of the numbers that we are given. So not necessarily number of sig figs, but how many numbers are past the decimal and the least amount between those. So we're going to look at number one. Number one gives us 5.58 times 10 to the second times 6.85 times 10 to the third. We are going to have to use a calculator for this. Some of you may have already been able to punch in scientific notation numbers into your calculator. Some of you may not. We're going to do a tutorial of that right now. So I'm going to type in 5.58, and then we're going to use the function of scientific notation that allows us to use times 10 to the exponent on our calculator. So all of you should have a second key, and there is a blue capital EE on this comma button that you are going to press that is directly above your 7. That capital E takes the place of times 10 to the exponent. So all we need to put in is the exponent on our 10, which is 2. So that takes care of the first number that we are multiplying. And now we need to do our second number. So times 6.85. We're going to press that second key again and the comma button directly above my 7 to represent times 10 to the exponent. So all we need to put in is a 3. Now, you need to check and make sure that your mode is correct on your calculator. I already have it set to scientific, but normally it's on normal. So you guys need to change it to scientific notation for this question specifically, as both of our answers or both of our givens are in scientific notation. If we didn't, our number would look really crazy. We could keep our answer with a big number, but if we're given scientific notation, we usually want to keep it in scientific notation. So my mode is on scientific notation. All I have to do is press enter and it will solve. It gives me an answer of 3.8223 E6. So that means that our answer is, let me zoom in here, 3.8223. That E means times 10 to the exponent, and our exponent was 6. Now we need to alter our answer. That's not my actual answer because we are referring to significant figures. So we're looking at our question. We have two numbers. There are 3 sig figs in our first number and 3 sig figs in my second number. Remember, if we're given a scientific notation number, everything before times 10 to the exponent is significant. So both of those have 3 sig figs. So we are keeping the first 3, and the third or the fourth one will determine if we're going to round that 2 up or keep it the same. So since it's a 2, we're not going to round up. We're just going to keep it the same. So my answer is 3.82 times 10 to the 6. And that is our final answer for number 1. Number 2, 0.000312 minus 0.00410. We are given a subtraction. We're going to keep that in mind for later whenever we're figuring out our significant figures for our answer, but let's go over to our calculator. We have 0.000312 minus 0.00410. Enter. Notice it gives me my scientific number. Okay, we're going to switch it back to normal so that we can get a normal answer. We don't want it in scientific notation if we didn't start with it. So I'm going to click answer and put it back into normal notation. So we are given negative 0.003788 as our answer. So I'm going to write that down. Negative 0.03788. Now we need to figure out how many sig figs we're going to keep in our answer. So we are looking at decimal places. This one has 6 total after the decimal. This one has 5. We can only keep 5. That's the least amount. So in my answer, I'm going to keep 1, 2, 3, 4, 5. And this 6th one will determine if we are going to round it up or keep it the same. We are going to round it up because that is an 8. So I'm going to move over to write my real answer, and we get negative 0.00379. And that is our final answer for number 2. Number 3, 8,443 divided by 1.20. We're going to move over to our calculator. We have 8,443 divided by 1.20. Enter, and we are still in normal mode, so we don't have to change it to scientific notation. So we get 7035.83333333. So I'm going to write my answer, my raw answer down here. 7,035.83333. We can put a number over that, or a line over that, saying that that's just going to keep going. Now we need to figure out how many sig figs we're keeping in our answer. We are dividing, so we're looking at the total number of digits between our two numbers. Our first number has 4 significant figures, and our second number has 3. Since that decimal is present, the 0 at the end is considered significant. So we have 3 in our second number. We can only keep 3 in our answer, so we have the top 3 that we are going to be keeping. Number 4 will determine if we're going to round our third one up or keep it the same. Since it's a 5, we will round up. Now we need to keep all of these numbers in their appropriate place values. So that 7 has to remain in the thousands. So it's going to be 7, 0. That 3 will round up to a 4. And then the 5 will drop off, and we're going to put a placeholder in there, which is going to be a 0. So we have 7040 as our answer for number 3. On number 4, we have 356.7 times 10. So 356.7 times 10. We're still in normal mode, so we can go ahead and use it. That's going to give us 3,567. So we have 3,567. Okay, we have to figure out, based on our question, how many sig figs we can keep in our answer. We have 4 sig figs in our first number, and we only have 1 sig fig in our second number. So we can only keep 1 in our answer. You have to keep the biggest one, and then your second one will determine if you're going to round it up or keep it the same. We are going to round it up to a 4 because that's a 5 or higher, and we have to remember that that has to stay in the thousandths place. So we're going to drop the 5, 6, and 7 and put zeros in as those places, because those zeros are not going to be considered significant. So we have 4,000 as our answer to number 4. Again, that 4 has to be in the thousands place because the 3 was in the thousands place. So we put in zeros behind it as placeholders. Those zeros are not significant because there is no decimal present. So that's how we end up answering that question. Number 5 gives us 4 numbers. We're going to be adding or subtracting. So we're going to go over to our calculator. We have 1,045 plus 875 minus 45 minus 120. Press enter, we get 1755 as our raw answer. So we have 1755 here. We need to figure out how many decimal places we can keep. This is an adding and subtracting, so it is about decimal places. All of these numbers are rounded to the whole number. They don't have decimals. So we are going to round our answer to the whole number. Now, our answer doesn't have any decimal places, so we're just going to keep our answer as is, which is awesome. And we can just write it on our, let me get rid of that. We can write it on our answer because it is the correct one to the correct amount of Sig Figs. Number 6, 134.50 divided by 5. We're going to go over to our calculator. 134.50 divided by 5 gives us 26.9. So we have 26.9. We have to figure out how many Sig Figs we can keep in our answer before we give it. So we have 5 Sig Figs here. Again, that trailing zero is significant because a decimal is present. And then our second number is 1 Sig Fig. So since we are dividing, we're looking at Sig Figs. The 1 limits us, so we can only keep 1 Sig Fig. The first one is the one that we're keeping. The second one will determine if we're going to round up. It is a 5 or higher, so we're going to round up to a 3. And then we're going to put in a place filler as a 0. So our answer becomes 30 instead of 26.9 to help with the significant figures. Number 7, we have scientific notation numbers, so we're going to change our mode on our calculator. But we have 9.002 times 10 to the 4th divided by 1.32 times 10 to the negative 3. We're going to go over to our calculator. I'm going to go ahead and switch my mode to scientific so I don't forget. I've got 9.002. I'm going to use my second key and my E key. And then we have 4 as our exponent on that 10 divided by 1.32 second E negative 3. We're going to press enter. It's going to give me my answer in scientific notation, which is exactly what I want. So I'm going to go ahead and go back to my paper and write down the raw answer that I get. It is 6.81969669. We're going to just go ahead and put a line over those. And then it had an E7, so it's times 10 to the 7th. And we are going to look at our significant figures. We're dividing, so we are worried about figures and not digits past the decimal. My first one has 4. My second one has 3. So I'm limited to 3 Sig Figs. My fourth one will be the determining factor if we're going to round it up or keep it the same. Since it's a 9, we're going to round it up, and my answer is 6.82. Oh goodness. 2 times 10 to the 7th. Number 8, 7 billion divided by 8,756.0. These are normal numbers. We don't need scientific notation. I was just in scientific notation on my calculator, so I'm going to go back to normal. Okay, so we're going to type it in. We've got 7 and we've got 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 8756.0. Enter. Okay, so it gives me a very large number as my answer. We're in 799,000. So I'm going to go ahead and put that onto my paper. The answer is 799,451.80447. It's a lot of numbers. Okay, so since we're dividing, we're worried about digits. How many significant digits are in here? My first number only has one significant digit. My second number has 5 significant digits. This trailing 0 on the second number is significant because a decimal is present. All of the zeros in the first number are not significant because there is no decimal present. So we're limited to one significant figure that we can keep. The second one will tell us if we're going to round, which we are. And we're going to, oh goodness, let me scroll. There we go. We're going to round that 7 up to an 8. And then we're going to put place fillers. So that 7 was in the 100,000 place. So we're going to put zeros until it makes it 800,000 as our answer. Number 9, we have negative 6.3 times 10 to the negative 4 times 5.6 times 10 to the 7th. So we are going to multiply those together. They are scientific notation, so I'm going to change my mode on my calculator to scientific. And I'm going to input those two numbers, negative 6.3. Press the second key and the E key. And we have negative 4 as our exponent on our 10 times 5.6, second E7, and then I'm going to press enter. We get negative 3.528 times 10 to the 4th. So we get negative 3.528 times 10 to the 4th. We are multiplying, so we're concerned with how many digits each of our numbers has. We have 2 and 2, so we can only keep 2 in our answer. We're going to keep the top 2. The third one will determine if we are going to round up or keep it the same. It's a 2, so we're going to keep it the same. So your answer is negative 3.5 times 10 to the 4th. And last but not least, number 10, 3.48 times 10 to the 3rd minus 4 times 10 to the 3rd. I'm going to go over to our calculator. We are in scientific notation, which we want. So I'm going to go ahead and punch in my numbers. 3.48, second E3 minus 4, second E3, enter. It gives me negative 5.2 times 10 to the second. So we have negative 5.2 times 10 to the second. We have to figure out how many significant figures we can keep in our answer. We are subtracting, so we're worried about how many digits are past the decimal. We have 2 here, and then there are none on our second number. There's not a decimal. So we can't keep any numbers after the decimal according to our second number. So we're only going to keep the whole number, and the first decimal will determine if we're going to round up or keep it the same. Since it's a 2, we're going to keep it the same. So your answer is negative 5 times 10 to the 2. So those are the calculations using significant figures. It's important for you guys to be able to use your calculator using the scientific notation function with our not only the mode being scientific, but also using the E key instead of times 10 to the exponent. I know you guys probably understand how to put that into your calculator, but you can make so many errors using that, and it's much faster once you use the E function. So that is how we do calculations with significant figures.